Okay, one last example on 5.6, specifically a proof. You want to prove that the triangles are congruent, specifically by angle side angle. So that kind of already gives you the last reason. But here's what's given in terms of the diagram and what's given for the proof. Segment AC bisects angle DAB, and then also it bisects angle DCB. So I could write that as my first statement. Segment AC bisects angle DAB and angle DCB. I mean, you could break that up and just say segment AC bisects angle DAB for your first statement. And then this could be the second statement, AC bisects angle DCB. But both of those are given. I'm going to combine them with each other and then make one statement. Then my next statement, if AC, that segment bisects angle DAB, you have to remember what it means to bisect. It means to cut into two congruent parts. So these two angles are congruent. Angle DAC is congruent to angle BAC by the definition of an angle bisector. And then it also states that segment AC bisects angle DCB. So if the segment bisects angle DCB, then these two angles are congruent. Again, by the definition of an angle bisector. So angle DCA is congruent to angle BCA. Again, definition of angle bisector. We want to try to prove that these two triangles are congruent by angle side angle. We already have the two angle parts here. So we need the included side between the two angles. And in this case, that's side AC for both triangle ABC and triangle ADC. AC is the same segment in both of the triangles. It has to be congruent with itself. So segment AC is congruent to segment AC. Do you know the reason? It should be the reflexive property. And if you just write that, that's fine. Even more specifically, it's a reflexive property of segment congruence, or you could also just say reflexive property of congruence. And if you look at what we have in the diagram, especially, these two triangles are congruent specifically by angle side angle. The side is included between the two angles. So I could say triangle ABC is congruent to triangle ADC, specifically by angle side angle, or ASA. We're done.